I've got this question for you, right? It's a jam question, and so as friends prepare for their jam on WAEC, just so. How about you think about this? The particle and wave nature of matter are demonstrated in the equation. Option A, wavelength equal to Planck's constant divided by momentum. Option B, wavelength equal to speed of light divided by frequency. Option C, wavelength equal to 2 times distance sine theta. Option D, wavelength equal to Planck's constant times the speed of light divided by energy of a photon. Which of the options there is correct? Now, before we move on into saying anything about what the correct option is, I'd like you to come along with me as I discuss briefly the concept of wave-particle duality, a paradox. Yes, this is actually a paradox because we are looking at a concept of light or matter, behaving as a wave and as well having this particle property. Is that not interesting? Duality of matter and light. And there is this wonderful equation. It is called the Broglie's wavelength. That, of course, is the formula that we are actually interested in according to the options provided. And so how do we establish the Broglie's wavelength? After establishing it, we can now go for what the correct answer is. So are you ready for that? Come along with me. But remember that I had already treated the concept of energy quantization and photoelectric effect, where we learned, according to Planck's radiation theorem, that energy of a photon E is equal to hf. All right, and we found out that frequency is equal to the speed of light divided by wavelength. So in place of that frequency, I can actually put the speed of light divided by wavelength, and this is going to give us hc divided by the wavelength. So what do we have? Energy of a photon, energy of light, is equal to Planck's constant times the speed of light divided by what? Wavelength. Now, we also know from Einstein's energy equation that E is also equal to mc squared. That is mass times the speed of light raised to power 2. When you talk about something that is a particle, that thing has mass. So this equation brings in a concept that light can actually have particle property. It's possible. And then coming here, we have this wavelength there. That wavelength also tells us that when you are talking about energy of a photon of light, that light can also have this property of wave. Because of course, when you talk about wavelength, it goes with the concept of